matrix equations. Today we are going to be solving using matrices and the inverse. Okay, so when you have a matrix equation, we are, instead of putting it in an augmented matrix, we're going to be putting it in a matrix where you have your x, your y, and your z. Okay, these are the coefficients of x, the coefficients of y, the coefficients of z. You multiply it by x, y, and z, and then it's equal to another matrix, which is going to consist of the constant terms. Okay, so this is matrix B here. You have the coefficients are the matrix A, and then you multiply that by x, your x, y, z. So if we let the matrices equal ax and b respectively, then the matrix equation can be written as ax equals b. Okay, where matrix A is your coefficient matrix. And then what we can do is we can apply the inverse to either side. Okay, so when we apply that inverse, we are going to multiply both sides by the inverse of A. Okay, or you can write it like this, A inverse. Okay, and that's if the inverse exists. Okay, and we are going to solve this below. So when you are solving, you are going to multiply each side by the inverse of A. You do have to write it just like I've written it, because when you multiply, okay, your multiplication is not commutative. Okay, so you are going to put the inverse, they have to be on the same side. You can't write it on this side, so it has to be exactly like mine. So then, according to our properties of multiplication, you can multiply those together first. What happens when you multiply an inverse by the matrix? You guys remember what you get? You get the identity matrix, yep. So we're going to call it I sub n times x equals the A inverse times B. And when you multiply the identity matrix by x, what do you get? An identity multiplied by a matrix is that same matrix, so x. So based on this process to solve, we can say if this is the matrix equation, to solve for x, we can go right to this step, okay? So if you are solving this equation, you're going to multiply the inverse by the B matrix, okay? And we have to multiply it on the left because multiplication is not this. Okay, so just to be crystal clear, if you multiply the inverse by ax, that does not equal this. Those are not the same. You can't do that. Okay, it has to be on the same side. So if this is on the left and this is on the right, those are not equal. Okay. Alright, so we are going to solve the matrix equation given by the system above. And our first step is to find the inverse matrix of A. So we're going to use what we did yesterday, which is we have to put the identity matrix next to it. And I'm fine if we just want to jump in and put the 1, 0, 0, 0, 1, 0, 0, 0, 1. Right, so that's a whole big matrix. Okay, our first step when you are finding the inverse is, remember, you want this side to be 1, 0, 0, 0, 1, 0, 0, 0, 1. So your first step is making sure this is a 1. Okay, it's already there, but if it wasn't 1, what could you do to make 1? You just multiply by the reciprocal. Okay, or if you had a 1 here, you could just flip those. Okay. So we do have that, which means our next step is we want, after we find the 1, we want the 2 below it to be what? Yep, so we want to make these 0. So we already have that leading 1. So this is where we can pull a 2 for 1, okay? When you are deciding what to multiply, always do the row with the leading 1. So if I want to cancel out 2, what can I multiply by 1 that's going to cancel out with 2 when I add them? Negative 2. So we're going to do negative 2 times row 1 plus row 2, and that's going to be our new row 2. Okay? So we're going to keep row 1 the same. It's 1, negative 2, negative 4, 1, 0, 0. Okay? And I want you to take the time now to do this process to find your new second step. Okay? That way if you make a mistake or you run into an issue, you can figure it out now. So when you multiply by that leading 1, okay, that's going to allow you to not change this 1 here. So negative 2 plus 2, this would be 4 plus negative 3. How are we doing so far? Okay, then we got negative 2, and then what do we get for the next one? 1 and 0. Okay, so what questions do we have there? All right, any questions about that stuff? Okay, so now we can do this at the same time. If you want to cancel out with negative 3, what's the opposite of negative 3? 3, so we're going to multiply row 1 by 3. We're going to add that to row 3, and we're going to make that row 3. Okay, we can do those at the same time because you're just doing the opposite of both of them. So 3 plus negative 3 is 0. Negative 6 plus 6 is 0. That's turning out nicely. Negative 12 plus 15, 3. 3 plus 0, 3. 0 plus 0. Okay, so we're multiplying everything in that row. And then we are adding it to row 3, and we are putting the result in row 3. All right, so now we have 1, 0, 0. The next thing we want to do is get a 1 here. But see how we already have it? Okay, and then the next thing we want to do is get a 0 here. We already have that. Okay, so then we just have to get a 0 above. Can you guys tell me how? Good. The reason why you want to do it like this is so you don't undo anything that you've ever done. So it's always the first thing. See how we multiply by row 1? Now we're multiplying by row 2. Okay, and then the last one will be multiplying by row 3. Okay, because this is where your leading 1 is. Again, a organization helps. Start thinking about your next step. check that. So on the top, did you get 1 and then 0, 0, negative 3, 2, 0? On the top. Okay? All right, so that's actually pretty nice because we have 1, 0, 0, we have 0, 1, 0. Now the next step, yes, this is already a 0, but you don't want to make this a 0 yet. You always want to get the 1 first. So before we even worry about making that a 0, we got to make this a 1. Okay, so how are we going to do that? Yep, 1 over 3. Oh, did you guys notice that I'm putting a little pumpkin in there? I feel like a couple of you were saying like, why can't you do this? And I never wanted to because it would like punch through something else on there. But this one turned out nice. All right, so then 0 times a third, 0 times 1/3, 3 times a third, 3 times a third is 1, 0 times a third is 0, and then 1/3 times 1 is 1/3. Okay, and that's all we change. So again, I do my best to keep these in an organized column because when I don't, that's when I make small mistakes. Okay, so now I have 1, 0, 0, 0, 1, 0, and then 0, 2, 1. So now I have to make this a 0. If this already wasn't a 0, you could do that in one step and that would be fine. So the reason why you have to make this a 1 first is so that you can multiply row 3 by the opposite. So if you look back, you can see, oh, I multiplied by my row 1, then I multiplied by row 2. Here I'm multiplying the opposite by row 3 because that is what is going to keep that the same. Okay? And again, if I know I'm only changing one of my rows, then sometimes I'll put my row 1 and I'll put my row 3 in here first. So I have negative 2 plus, or I guess I need to start here. So 0 plus 0. This will be 0 plus 1. This will be negative 2 plus 2, which will be 0. This is negative 2 plus negative 2, which will be negative 4. This will be 0 plus 1. Negative 2 times 1/3 is negative 2/3, and then I'm adding that to 0, so it's not so bad. And then what you end up with is, remember, this is the identity. So this here is your inverse. Okay, so the inverse of A is negative 3, 2, 0, negative 4, 1, negative 2/3, and then 1, 0, 1/3. Okay, so the first step is finding the inverse, and that's because you need to multiply A inverse times B. Okay, so we're going to multiply A inverse times B. So that's also something we already know how to do. So we're doing the inverse multiplied by the matrix. Okay, so our inverse was negative 3, 2, 0, negative 4, 1, negative 2/3, and 1, 0, 1/3. Okay, and then when we multiply that by B, okay, matrix B is the 750. Okay, so this is our matrix. This is matrix A. We found the inverse. Matrix B is 750. So when you are multiplying, we have a 3 by 3 and a 3 by 1, which means the result is going to be a 3 by 1. So this is going to be a 3 by 1. All right, so let's go ahead and multiply. So first row, first column. Again, I like to do it like this. Okay, I want you guys to put what you're adding together. You don't have to write out each multiplication. You can just write what the product is. 7 is negative 21. So this is what I want you to write down here. So negative 3 times 7, negative 21. 2 times 5 is 10. Anything times 0 is 0. So negative 21 plus 10 is negative 11. So now we're going to do the second row, first column, because there's no second column here. So negative 4 times 7 is negative 28. Then you do 1 times 5. Then you do 2/3 times 0. So what did we get for that one? Yep. And then the last one, we have 7 plus 0 plus 0, which is 7. Okay, so negative 11, negative 23, and 7. Okay, so that is going to be your final answer. Okay, so x equals negative 11, negative 23, and 7. Okay. Alright, so we have just proved that this matrix equation can be solved using the following method, which is an information box in your beautiful textbook. Solving a matrix equation. Okay, so remember that multiplication is not commutative, therefore, yes, we already wrote this down once, but okay, so cannot multiply those together, okay, in that order. Alright, so for example 2, a system of equations is given. We are going to write the system as a matrix equation. Alright, so you're gonna write matrix A, then you have matrix X, and that's going to be equal to matrix B. Okay, so I want you to do that for this system here. Yeah. We are going to solve this one with our graphing calculator, okay? Alright, so there's no x, so what should I put here to start? 0. So 0, negative 2, 2, 3, 1, 3, 1, negative 2, 3. Okay, in the column for the x, it's just x, y, z. And the column for b is all the constants. So 12, negative 2, 8. Okay, so we're gonna I'm gonna show you how to do this on your calculator. You'll be elated and filled with fury all at once, I'm sure. Okay, so this is what we're gonna be multiplying together. Okay, so the first thing I'm gonna do is I'm gonna show you how to find the inverse with your calculator. Alrighty. So, hello, good friends. You may have noticed the word matrix right here. Okay, so we're going to go to second matrix. And some of you might have that. I'm going to assume most of you do not have anything in there. Like, you might not have this one by one. Okay, so you're going to go over, arrow over to edit. Okay, and then you're going to press enter. So for matrix A, we're going to plug in matrix A. Okay, so in our calculator, we're going to plug in matrix A. So you go to matrix, you go over to edit, and matrix A is a 3 by 3. So when you type in 3 by 3, it'll give you those entries. Okay, so we're just going to plug them in. So 0, enter, negative 2, enter. They do go by rows, so it'll go straight across. 3, 1, 3, 1, negative 2, 3. Okay, that's your first step. So enter that in. need to have the problem solving skills. Unfortunately, your brain needs the exercise, not the calculator. Okay, so once you have that in here, we're going to quit. So second quit. Okay, and then we're going to go back to the matrix. And then, I actually think there's two ways you can do it. Put your phone away.
That's just a calculator.
Okay, and then we're going to do the inverse. So you can use this inverse button, and then I think there's actually another way to do it. I'm going to double check. Yeah, right here, the x to the negative 1, press enter. Oh, it's so fun. Okay, and then we're going to write down the inverse. Don't. Yes.
I put my numbers in the thing.
Okay, to get out of that screen, just go to quit, second quit. Okay, and then you should get a blank screen, right? Okay, so then you're going to go back to the matrix, so second matrix, and then you should have A defined now, and then you can just press enter, and it should appear on the screen, and then there's this inverse button, this x to the negative 1, so if you push that button and then enter, okay, it will give you the matrix of A. And if there is no inverse of the matrix A, okay, then you will get an error. Okay, so that is our first step. All right. Our next step is we have to multiply by B. Oh, I also want to try this. So underneath the matrix, if you go to math, I saw an inverse one earlier. Or maybe it was that. Maybe it was okay, no. All right, so then now we're going to go to B and we're going to edit B. So B is a 3 by 1. Okay, and then when you do this, you're going to have 12, negative 2, and 8. Okay, practice this with me because you are going to have to know how to do this both ways. Okay, algebraically and with your calculator. Okay. All right, so once you have that entered, you're going to quit out. So second quit. Okay, and then you can go to second matrix. We're going to do A inverse, but don't press enter. We're going to do times the B. Okay, so we're going to go back to matrix. We're going to select B, and then you can press enter. Okay, and so when you are multiplying them together, you are going to get your value for x. And again, this is a 3 by 3 and a 3 by 1, so your answer should be a 3 by 1, negative 20, 10, 16. Okay, another cool thing that you can do with this is if we put in a matrix equation, sorry, can you see that? Negative 20, 10, 16. There's a little electric up there. Okay, I'm going to show you how to clear this out. So we're going to clear, we're going to go back to the matrix, and then if you want to make A something else, just go back to edit, and we can make this into an augmented matrix. So let me show you how to do that. We're going to make it a 3 by 4. So remember when we were first doing these, we did the augmented matrix. So this last column would be 7, and then a 5, and then a 0. So we already have that. So we just put that in as well for matrix A. And then to solve, we were putting those in row echelon form and reduced row echelon form. So if you quit this, second quit, if you go to the matrix again, okay, it is going to have a list of operations you can do. And if you go down here to RREF, you can go to second matrix, tell it you want the reduced row echelon form of A, okay, and then it will tell you what the reduced row echelon form is of A. Okay? So then you have the 1 there. Okay? All right, so what you're going to work on today is 10.5. These are the ones that you're doing by hand. And then when you're doing these, you are using the inverse from your homework problems, okay, as it directs in the textbook. So you're not going to be doing these twice. So I chose these so that you could line them up. Okay, so yesterday you guys did these problems. Okay, so that's what you're going to be using today. And then 33 and 34, you're going to be using your calculator. Okay?